Hi guys, this is Intro to Machine Learning, and this is the first meeting. This occurred on July 1st, 2022, and I'll get started. Okay, so for most of you guys, this should be your first class with Neuracode. I hope you're excited to learn about machine learning. My name is Sanvi. I'm going to be in 11th grade next year, and I hope you guys will enjoy this course. Okay, so this is the first class, so I'll be going a bit slowly, and there is a bit of content that is important for the rest of the course, so it's important that you guys understand it now, so you can build your knowledge on it for the rest of the course. So, of course, there are some complex words here and there that I'll be using, because machine learning can get very complicated. But because this is still an intro class, I will be giving you guys simplified definitions and synonyms for some words. Now I'll move on to an overview of the class. So what can you expect from this course? We'll learn what machine learning is and why it's used. What makes machine learning different? Some machine learning algorithms, and we'll also learn a machine learning pipeline. This class contains no prior knowledge or prerequisites in order to learn machine learning, and we'll be introducing machine learning concepts as we learn, and our development language, our main coding language, will be Python. You don't need to have a prior knowledge of this either. Just make sure you pay attention on the way so you can do your best in this class. So what you can expect from this course, as I said earlier, you don't need to have a background in anything. You can check for our Python courses that Neuracode offers in our website, but you'll be able to learn the machine learning concepts in just enough depth, and the knowledge that you learn here will be transferable across any coding language as long as it has machine learning libraries. The knowledge, however, we don't go into deep mathematical theory of machine learning. For example, we won't go into an in-depth analysis of mathematical equations behind a particular machine learning algorithm or explain why it works the way it does. You can find that on academic papers or Google. You don't need to worry about it right now. So now I'm going to show you guys a really academic definition of what machine learning is, and it's from Wikipedia. After you guys can read it, but I'll also read it out loud. So machine learning is the scientific study of algorithms and statistical models that computer systems use to perform a specific task without using explicit instructions, instead relying on patterns and inferences. So that was a lot of words. So an easier definition is you teach a machine learns. Hence it's called machine learning. Okay, so now I'll talk about more technical stuff about machine learning. So the first point is it's a scientific study, which means that there's a lot of academic research and effort supporting its growth and development. And it relies on algorithms and statistic models, which tells us that if we want to master machine learning, we need to develop a pretty good understanding of algorithm, statistics, and probability. Those are going to be some key words that I'm going to be using, and that's going to be mentioned throughout this course. The third point is machine learning aims to perform a specific task, which tells us that a machine learning solution has a particular scope or a particular goal, such as prediction and recommendation. No explicit instructions. That's the fourth point. This tells us that we should not program our machine learning situation in an exact way to teach it how to do things. Relying on patterns and inferences, that's the fifth point. This tells us that our machine learning situation will rely on digesting certain patterns from the historical data to learn how to function properly. By this, let me give you an example. It's a lot easier for humans to just do things without thinking much, but machines need almost step-by-step experience, step-by-step instructions, and experience doing things. For example, when you go to get a cup of water, you're thinking, okay, let me just grab a cup, fill up the cup, and then drink it. Or maybe you're not even thinking because you've done it so much. But a machine could be thinking, okay, according to what I've learned, I need to open the shelf door, grab a cup, reach my hand out and turn on this thing, blah, blah, blah. You guys get it. So it's pretty crazy. And to bring in the three words that I mentioned earlier, algorithms, statistics, and probability, When the machine has experienced various different scenarios, it starts noticing patterns and uses statistics and probability to sift through a situation. That was a summary of kind of what machine learning is. And now we're going to talk about applications of machine learning. Where is it used and why is it used? So some real world applications of machine learning that we see in our daily life is first, image recognition. You guys probably have seen iPhones and the Face ID that they have. There's iPhone 10, 11, 12, 13 that have Face ID. So maybe one of your guys' friends or parents have that phone, or even you have it. Have you ever wondered how your mobile phone can unlock itself by just passing your face in front of it, but it can't unlock itself for other people? Well, that's due to the image recognition technology that's running that method. By properly feeding the image data to a machine learning algorithm, it can recognize objects. And another example of machine learning in the real world is voice recognition. So you guys might know Siri, Google Assistant, or Alexa. This machine learning makes it possible to identify the user quite effectively to the extent that it was a reliable security method. There's security sources where people can scan their voice and it'll unlock, like, the security will be fine with it. So that's all because of machine learning. So now it's worthy of discussing why machine learning is getting such attraction nowadays. Like, there's a reason to why you're taking this class and why you want to learn more about machine learning, because it is so reoccurring in our current world. Believe it or not, it has been there since the 60s, but there have been some driving forces pushing it in the last few years. High dimensional problems are now becoming a thing. So high dimensional means that there are so many dimensions or sides to a scenario that calculations are really hard. A high dimensional deficit, a deficit being a decrease in a value, is a deficit that has way too many attributes, making it almost impossible to analyze using traditional programming. Hence, machine learning is the other option. An example of a highly dimensional data set is the health status of a patient where many attributes such as genetic background, nutrition, and any operations they've had in the past. Other than this situation, there's also a massive data overflow in general. Web services, databases, email, surveys, you name it. Businesses have recently seen the need to find an efficient way to understand these massive deficits and instead of losing value, gain value. So there are some countries these days that are really looking for oil. Like, oil is so sought for, sorry about that, because it is rare and it's very necessary in our world and it has high value. Machine learning research, similarly, has significantly grown in the last decade, and businesses have started to understand its value as many algorithms were researched and developed and skills were trained. So given all this previous information, we can confidently reassure the statement that's shown on the screen: data is the new oil. So I was talking about traditional programming earlier, and you guys are probably like, okay. So let's get to that. I will now describe some differences between programming and machine learning. 1 second. Okay, so why don't we just program our business rules and domain knowledge into our machine learning models just as we do in traditional programming? That's a really good question to ask right about now. And in other words, what is the actual difference between machine learning and traditional programming? I'll go in depth about the differences between the two now. In traditional programming, we capture the full domain. For example, if we'd like to calculate the salaries of for a certain company, we will have a clear business rule for each scenario, and we know exactly how it'll look. We have a full understanding of the business domain. In machine learning, on the other hand, while we don't fully understand the domain model, we sort of know how the system reacts for certain inputs and outputs. But at the same time, we don't really fully understand the underlying complex relationships between the input and the output. So yes, we can give all these inputs and outputs to the machine learning, but we don't really understand what's going on inside. So basically, it's just a very well-educated guess. So now I'll give you an example for this. A machine learning algorithm can classify customers to different groups based on the similarity of their purchasing behavior. And even though we don't fully understand the underlying complicated relation between these different customers, delegating the task to a machine learning algorithm makes much more sense because it just guesses and assumes. So that was a summary of the first point and some examples of it. I know right now you guys might be a little confused with what I'm saying, but I will be going over this stuff in the next meeting to make sure that you guys understand it again. And also, you don't need to worry about knowing everything right now, because as the course continues, you guys will understand everything eventually. Okay, so now I'll get to the third point or the fourth point. You guys will understand. In traditional programming, the system is aesthetic and mostly static. Changes should be mainly made by changing the source code, which is the official programming statements made by the creator, or you can change the configuration. For example, if we would like to add a new rule for a salary system that I mentioned earlier, we have to modify the source code. So the only way around traditional programming is to look at the main rulebook and change things there. But in machine learning, the system is dynamic and continuously learning and adjusts based on input and new learning certificates. And the customer grooming algorithm that I mentioned earlier, where the customers are separated into different groups based on their purchasing behavior, this can get better with time as it learns more trends and recognizes more patterns. And that was a summary of the second point. Okay, again, I know you guys might have questions about this, but I hope that your doubts are cleared in the next meeting or as I keep speaking. Okay, and then here is the third point. While in machine learning, we require a lot of data to learn from it, for example, to classify our customers properly, our machine learning algorithm needs to see enough samples to understand the underlying relationships. Our customer grooming algorithm needs historical data to learn from it. And that was the third difference between programming and machine learning. Okay, let me just summarize that really quick. A machine needs to be able to get all this data, remember it, learn from it, and gain experience to be able to continue to do it. But in traditional programming, you kind of just give it, there's a rule book, it follows it, and it's done. So in traditional programming, it's kind of just static. It doesn't really progress in any way. But in machine learning, like I said, it can get better and better. Finally, the last point is, in traditional programming, the logic is easy and it's straightforward. We can easily read the source code to find the truth. That was kind of the whole differences between programming and machine learning. And don't worry if the stuff doesn't make sense now. It will all start to connect when we get more into depth in this course. Okay, that was lesson 1. I know, a lot of content, but that is okay. So now that we know what machine learning is and how it differs from the regular programming approach, it's very important to develop an overall understanding of different types of machine learning algorithms. For the ones that don't know, an algorithm in computer science is a set of instructions for solving a problem or accomplishing a task. In this scenario, in this case, each algorithm group has its own way to learn, calculate, and so on. So the types of machine learning algorithms are supervised learning, unsupervised learning, and reinforcement learning algorithms. And now let's dig deeper and see how each of them works. So now we're going to start off with supervised learning. This is the easiest to understand out of the 3 main types of machine learning algorithms. The main difference in supervised learning is that it has input and output data as well as labeled data. This means that we must use previously collected data to train our model rather than letting it do everything on its own. Labeled data, from the 3 data types I mentioned earlier, is data that has been tagged with identifiable information, which allows the machine learning model to learn. So that was a really complicated definition, but to simplify, it's basically just a water bottle. Imagine a water bottle and it just has a label on it saying water bottle. So by giving our model this type of information, it's able to learn from these labels and use the labels to solve problems in the future. So like, as I mentioned earlier, you're probably looking at a water bottle and you know it's a water bottle. You don't need to have it labeled. But for a machine, it only knows that it and only recognizes the thing as a water bottle if it's labeled. So that's the first kind of data. For example, in the diagram above, we are feeding our algorithm banking data that has been collected from customers and previous sales. After the algorithm learns from this, we are able to predict any future sales using the information from the past. And guys, I mentioned earlier historical data, that's where this comes in. When we say we have input and output data, this basically just means that our model requires an input data source to work. So you kind of need to give it information so it can give us some interpretations of that information as an output. So this could be anything. This input data, it could be anything. It could be a picture, a car price, a car model, or even just a bunch of words. So the user passes in one of these data types to our model, and our trained model is able to return us output information, which could be a price prediction or a classification. And I'll be talking about that now. So you guys are probably thinking, it gets more complicated? Well, don't worry. My duty is to make sure you guys understand. So in supervised learning, there are two well-known types. These are regression algorithms, which is when the predicted value is of a continuous nature or anything in a certain range. An example for this is sales forecast, and it can be any value, 13,000, 100, 150, or even a million. And the other type is classification algorithms, which is when the predicted value is of a discrete nature, which means we have a specified set of possible options of the predicted value. For example, a retail shop may classify customers as high profile, medium, and normal, nothing else. However, our focus in this course will be on regression algorithms. So all you need to know about regression algorithms is just that it's just like a number and it's a continuous nature or just anything in a certain range. Let me switch over to a different slide right now. Okay, so this one. Right here, regression algorithm, that's a really good definition right there. So a model just outputs, a model or a graph, outputs a continuous numerical value. I'm sure if you guys are in algebra or, algebra 1, 2, pre-algebra, you guys have heard of, graphs and regressions. And that just means like a line on a graph. And model outputs a continuous numerical value. Give me a sec. And this is give me a sec. Okay, next I'm going to be talking about unsupervised learning. So this is our second type of machine learning algorithm. Unsupervised algorithms are when you only have input data and you don't have any output data. So basically there's no ground truth. Our aim here, or our goal here, is usually to understand the underlying data structure to be able to use the data correctly. These algorithms are also called self-organizing algorithms. So now I'll give you an example. Let's say that we have a certain data set that we denote with the letters A through L, and we would like to find relations or associations among these data set members using an unsupervised learning algorithm. How we organize these relationships and associations depends on the type of the underlying unsupervised learning algorithm we are using, or in other words, an almost random set of rules that only the machine knows about. Hence, it's called unsupervised. As we have seen, rather than relying on feedback as the supervised algorithms do, the unsupervised algorithms rely on identifying commonalities and even differences among the dataset, either in the form of absence or presence of certain features. So there's also types of unsupervised learnings. So two well-known types of machine learning algorithms that follow unsupervised learning approaches are clustering and association. So the clustering type of algorithm is used when we intend to group a particular data input. For example, customer segmentation is where we split up customers by groups to currently show them. In this example, we're going to be splitting up the customers by groups to correctly show them advertisements. So a clustering algorithm can spot the customer characteristics such as age, living area, income level, and gender. By the way, this is just an example. This is not what the algorithm is limited to. There are many different clustering algorithms like k-means clustering. K-means clustering aims to partition data into k-clusters in a way that data points in the same cluster are similar and data points in the different clusters are further apart. Similarity of 2 points is determined by the distance between them, and there are many methods to measure this distance. Now this is the second type, association. These types of algorithms aim to establish associations among data elements in large databases. It aims at finding out useful relationships among variables. However, unsupervised learning is not discussed in this course. So basically, all of that was a little useless for this course, but it is very good to know about because, you'll learn more later, but to know that these things exist will help you develop your knowledge on what we will learn. Okay, this is the third type and the last type that I'll be going over of machine learning is reinforcement learning. This is also called goal-oriented learning, but I'll just be calling it reinforcement learning. These types of algorithms aim to make software agents, which is another name for reinforcement. Reinforcement learning algorithms learn from their surrounding environment by utilizing the notion of commutative, which means order of elements does not matter, rewards, and perform a task. I'm sure you guys have learned in math class the commutative property of math, where when you're adding two numbers, it's either 3 plus 4 is the same thing as 4 plus 3. They both equal 7. So that's kind of what it is. Same with multiplication. 3 times 4 and 4 times 3 is the same thing. They both equal 12. Okay, so continuing on this, an agent, which I said earlier was something that reinforces or, performs reinforcement. An agent decides to perform an action in this environment, and then the agent learns from this action. So look at the graph on the screen. The learning is fed back to the agent in the form of environment, state, and reward. Using that, the agent clears and updates its internal policies and gets more experience. These types of algorithms aim to solve a complex problem of our many steps, such as solving the complex game, if you guys have heard of it. If you guys did not understand any of that, that is okay. Again, just like unsupervised learning, it is not taught in this course. The enforcement training algorithms start from a blank slate, and gradually it improves performance by using proper incentives. Reinforcement algorithms are typically used in autonomous systems that make decisions without human guidance. Reinforcement algorithms, like I said, are also considered an advanced topic and therefore are not discussed in this course. Okay, now we're going to look at the learning modes or learning methods in machine learning. There are batch learning methods and online learning methods. These are machine learning methods that are used in end-to-end machine learning systems where the model is trained using all available training data in one shot. Online training methods operate in a different way than batch learning methods. The training data is usually put in multiple incremental batches to the algorithm. These batches are called mini batches. In a nutshell, the difference between the two types is how we feed the training data. Okay, so finally, it's useful to compare and contrast learning types from two different dimensions, objective and learning source. This chart is really helpful in the beginning of the course, so I'd recommend you guys take a screenshot of this. And it's just basically a summary of what we've learned today. Again, I'm aware this is probably a lot to digest today, so let me know as I summarize now and click through the slides again if you did not understand anything. I know because this is recorded, you guys are not able to do that, but I'm going to slide through them anyway, just so you guys can take a look at them. So Let's look at the chart before I do that. Supervised algorithms have goals of predicting future values or categories, and their learning source is that output dataset. With unsupervised algorithms, they aim to organize the data based on the underlying structure, and the learning source is the input the data returns. The reinforcement algorithms adapt based on the rewards and state from the surrounding environment. And the learning source, of course, is the surrounding environment and the rewards. Okay, let me go through all the slides again so you guys can just see what we went over today. Okay, so that was the last part that we left off at today, and that is a really good stopping point for today, and we will pick up where we left off in the next meeting. Thanks for joining me today, and it might seem like the information is confusing to you guys, but it'll start to make sense when we start to cover some more of this info in more depth. Thanks again, and I hope you guys stay for the next video.